Assalamualaikum and hi, my name is Muhammad Aslam bin Asri and my matric number is CE19007 and from section 7 in Mat 4. Now I want to start my presentation for introduction. A lot of news we have heard about bad incidents that stem from excessive alcohol intake as well as it has many adverse effects on society and the country. Alcohol has been damaging to society since time immemorial. Continuous alcohol consumption can result in countless loss of life as well as cause misery to millions of people around the world. Alcohol is the cause of many problems faced by society today. The statistic of rising crime rates and increase in case of mental illness and the collapse of family institutions around the world are silent testimonies to the destructive power of alcohol. When intoxicated, a person will lose coordination of gesture and also disturbance to judgment and sanity of mind. They can fall, have accident, fight, get injuries, and memory blackout, which are complications or short-term harmful effects related to alcohol consumption. So from this, we must take note and take seriously this case. What we want to solve? Alcohol is a well-known thing in Malaysia and is that one of the countries that has factories that produce it. Therefore, it is not uncommon for many people in Malaysia to drink alcohol, so that there is a lot of risk of harming themselves and other communities. There are many ways can be done for cope to reduce this problem. Accused such as have a goal, set a limit that can be to drink at a rate that is not intoxicating. In addition, it can reduce the rate of alcohol-related cases in Malaysia by giving severe punishment to offenders who are found guilty, so that the community is more sensitive and emphasize that this offense is very serious. With such punishment, society is more concerned and emphasize that it should be avoided. In this project, our group has proposed to make a device that uses an alcohol sensor placed on the driver's seat to detect if the driver is under the influence of drug. With a detector like this, it can give a warning and action can be taken earlier. With facilities like this, it can avoid unwanted problems and can prevent bad incidents from happening. This slide is about why we want to solve it. To our project, our group is to calculate the new analog value at 35% of the 0.50 L alcohol concentration, which is around 0.185 GL that is needed to the sensor to detect alcohol in our body. That is put in a car, so that the sensor will trigger at 0.185 L and will send the notification via our mobile phone. From below, that's our plan to do it. The first is to find the accurate analog value in the sensor to detect alcohol in the body to avoid an accident. The second is can prevent dangerous things from happening and can reduce the rate of accident and deaths caused by drunk drivers. And the last is prevent from facing dangerous risks caused by excessive alcohol in the body. This slide is about the authentic problem or real data used for the problem. The idea is from the research from the article and project about IoT-enabled alcohol detection system for road transportation safety in smart city. This is because many of the cases of an accident cause of high alcohol content in the body. This high of death and other case report cause effect of alcohol, and it can also have a detrimental effect on society and the country if not prevented.
Assalamualaikum warahmatullahi wabarakatuh and hi. My name is Ariffi Ardani, minutes number DE10166. Okay, I will present to you about the methodology for our project. Okay, so how to solve this problem? Our project is use two ways to solve our problems, which is manual calculation and then Microsoft Excel calculation. Okay, in the manual calculation, we use two methods, which is we apply the interpolation. So for the first method is a Lagrange interpolation method, and the second one is a Newton divided difference interpolation method. And then for the Microsoft Excel calculation, we use also two methods to solve the calculation, which is for the first one is the Fourier function and the second one is Newton's divided difference. Okay, first let's take a look for the Lagrange interpolation method. So what is the Lagrange interpolation method? So Lagrange interpolation is the process of the approximating a function of fx. So this method can estimate the missing function value over the interval a and b. Okay, as you know, Lagrange interpolation have four approximations, which is for the first one is the linear, second one is a quadratic, third is cubic, and the fourth is the quartic. So we go for the first approximation, which is the linear. This is the linear of the table approximation. So the linear approximation that passes through the 2 points. So this is for first point and this is for the second point. So this is the formula of the linear approximation. There has only 2 points, and this also in terms of the P1x. Okay, next we'll take a look for the second approximation, which is the quadratic approximation. So the quadratic approximation passes through the 3 points, which is this the first point, this is the second, and this is the third point. So for the formula, this also we need to apply the 3 points, which is this first, second, and third, and also this in this form. Okay, next the third approximation is the cubic approximation. So the cubic approximation is use the 4 points. So there has a 4 point, 0, 1, 2, and 3. And also in this form of the formula, there's also a 4 point, 0, 1, 2, and 3. So this is the cubic, which is the P3x. Okay, last but not least, for the last approximation, which is the quartic approximation. Okay, quartic approximation that passes used to the 5 points, which is the 0, 1, 2, 3, and 4. There's a 5 points. The same to the formula, which is also the 5 points, and also this form. And the quartic approximation is the P4x. Okay, now we look for the second method, which is the Newton divided difference interpolation method. So what is the Newton divided differences? So the Newton divided difference interpolation method can find the data which does not exist in the given data. Okay, this method is also for the first method, but this is assume that the given set of data is like that. So okay, when we assume the data, so we can generate the polynomial degree of n. So this is the form of the Newton divided difference. So we must identify the first Newton divided difference and also the second Newton divided difference. After we generate the polynomial degree, we should do the last calculation, which is we need to identify the Pn of x. So we can see the result that missing from the table. Okay, next let's take a look for the result and the discussion. So for this part, the result and the discussion, we discuss about the Lagrange interpolation method. So as we know, we use the 2 ways. So for the first one is the manual calculation, and the second one is the Microsoft Excel calculation. For the first one is the manual calculation. Okay, before that, I will show you about our data case, which is this is our data case. This is the sensor of the alcohol. So in this case, we want this new sensor to detect at the 0.185 gram per L. So when we want to set the sensor to trigger for this value, so what the analog value should we set? So as we can see here, there has a start analog value is 320 until 87, and the BSC value is the 0.66 until 0.18. Okay, as we know, the sensor will detect the alcohol concentration at the 0.5, but we assume that we must prevent earlier, so we need to sensor to read the earlier of the BSC value. So the 0.185 is between 0.19 and 0.18. So we must know the analog value here to set the sensor and to trigger the sensor to read the alcohol concentration. Okay, so we assume that BSC is X and the analog value is Fi. Okay, so For the Lagrange, we know there is a 4 approximation. So for the first one is the linear. So we take the 2 points, which is 0.19 and 0.18. So we put in the formula, which is there has need 2 point P1x. So after we calculate, we identify the value of the analog value is 90.5 or 91. Okay, next is the quadratic approximation. Okay, for the quadratic approximation, we use 3 points. So we take from table that start from 0.28 and end 0.18. Okay, after we put the value of this table in the formula, we can identify the final answer is the 90.5759, which is 91. Okay, next is the cubic approximation. Cubic approximation is need to do to use 4 points. So we take from 0.32 until 0.18. Okay, after we put the value in the formula, we get the answer is a 90.6192, which is a 91. Okay, last but not least, the quadratic approximation. So with the quadratic approximation, we know we must take the 5 point, which is start from 0.53 until 0.18. So after we put in this formula, we can identify that P4 is the equal to 90.6363 or 91. Okay, so after we finish the manual calculation, we start doing the Microsoft Excel calculation. Okay, for the Microsoft Excel, we use the focus function for this Lagrange. So the focus function will set in this box, which is this equal to focus function. So we reform the table, and we just set the 0.185 for the analog value, for the BAC value, and we can identify the analog value Fi, which is around 90.19106. Okay, so the last for the comparison of the result. Okay, this is the comparison between the manual calculation and the Microsoft Excel calculation. So for the manual calculation, the first one is the linear, second one quadratic, cubic, and quadratic. Okay, there's the four value is look same, which is when we run off, we can get 91. So for the Microsoft Excel calculation, we get 90.90. So this is only 90. But the value is between 94 and 87. So for the last final value is, we assume that the value of the analog value or Fi is the 91.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Hazizan bin Kadir, BE31602, and we'll presenting about the second method for our assignment, which is the in the chapter interpolation, the Newton divide difference. Okay, we can see this is the table that I made before, and with the data that I include. So first of all, we insert the BAC as the X and the analog time as the Fi0. This in this calculation, we have 5 steps, which is the first Newton divide difference for the analog time here to get the value for Fi1, and next second Newton divide formula to get the second Fi, and then so on until we get the final value for Fi with 5. So this is the final value. So now after we get all the value, we need to find the P, which is the P5 Fx. So we add all this number on the first row and multiply with the BAC here. So this is the formula for Px5, and then with the value of Fx, which is 0.185, we get the value is 90.6465, same as the Lagrange interpolation calculation. Okay, next is about to declare the answer we get in the manual calculation. So we use Microsoft Excel. to prove that the answer we get is the same with the manual calculation. So after the calculation that I made with the fx as 0.185, the answer are the same with the manual calculation, which is the 90.6485. Okay, for the conclusion part, we acquired many numerical methods to apply in our daily after studying engineering mathematics 4. We have utilized numerical method like Lagrange interpolation and Newton divide difference to determine if the value is highest and help us to create a graph more correctly, among other things. And in this assignment, to evaluate if the value is valid or not, we run calculation simulation using Microsoft Excel 360 software to compare the manual and the simulation calculation values. We can see from the previous procedure that there is only a -0 mistake between the manual and simulation, which is the absolute error. And as the result, our team has efficiently completed the goal of analyzing the technical problem and providing the solution utilizing numerical approaches. Okay, that's all from me. Thank you.